In this video, we're going to do an example of finding a Maclaurin series by the definition. So, the function that we're interested in finding the Maclaurin series for is f of x equals e to the negative 2x. We're also asked to find the radius of convergence. Well, if we're going to do this by definition, we need to start taking derivatives of the function, plugging in 0 for x into each of those derivatives, because again, we're asked to find the Maclaurin series, and then looking for a pattern for the nth derivative. So the function is e to the negative 2x. When we put in 0 for x, we get 1. Derivative of the function is a negative 2 e to the negative 2x. Put in 0 to the function, we get negative 2. Let's do a couple of more, make sure we have the pattern. Take the second derivative, we get a positive 4 e to the negative 2x. Again, put in 0 for x, we get 4. Put in the third derivative, taking the third derivative, we get a negative 8 e to the negative 2x. Put in 0 for x, we get a negative 8. All right, so what's going on? Notice that the sign is alternating each time. We've got a positive, negative, and it goes up by a factor of 2 each time. So the nth derivative here will be negative 2 to the n, e to the negative 2x, and we put in 0, we'll get a negative 1 to the n, 2 to the n. We rewrite it that fashion. So this is our formula for the nth derivative at 0. So we put that over n factorial times x to the n, and that gives us our Maclaurin series for f of x. To find the radius of convergence, since we've got a factorial in here, it's easier to use the ratio test. Do the limit of the absolute value of the ratio of consecutive terms. Oh, what pieces match? The 2 to the n plus 1 over 2 to the n. I could write the 2 to the n plus 1 as 2 to the n times 2. We would reciprocate here when we divide. We multiply by the reciprocal. So we'll have an n factorial over n plus 1 factorial. We've got the n plus 1 factorial can be written as n plus 1 times n factorial. X to the n plus 1 over x to the n gives us just an x. The absolute value actually applies to that x because it could be positive or negative. So we have absolute value of x sitting here. Things cancel. 2 to the n's cancel, leaves the 2. N factorials cancel, leaves the 1 over n plus 1. And then times absolute value of x. Now again, we were looking at this limit for a fixed value of x. If x is fixed, n gets arbitrarily large. This gets arbitrarily small, so the limit's 0 no matter what we plug in for x, which means that no matter what we plug in for x, this will converge, so our radius of convergence is infinity.